Hello friends, in today's question, the ratio of the surface tensions of mercury and water is given to be 7.5 while the ratio of their densities is 13.6. Their contact angles with the glass are close to 135 degree and 0 degree respectively. It is observed that mercury gets depressed by an amount h in the capillary tube of radius r1 while water rises by the same amount h in the capillary tube of radius r2, then the ratio of r1 by r2 is. So it's a direct question that is based on the formula, and we know that the capillary rise or depression of the liquid inside a capillary is given by, the height is given by h, which is equal to 2 gamma cos of theta divided by rho gr, where gamma is the surface tension, theta is the angle, r is the radius, and g acceleration due to gravity, rho is the density. So we can directly start from the formula. We are given that the capillary rise or depression for liquids in a capillary tube it is governed by the formula that h is equal to twice gamma cos of theta divided by rho gr, where h is height or depression of liquid in capillary tube gamma is the surface tension of the liquid theta is the contact angle between the liquid and the tube. Theta is the contact angle or angle of contact angle between the liquid and surface in the tube rather, and rho is the density of the liquid, g is the acceleration due to gravity, and last one r is the radius of the capillary tube. Radius of capillary tube. So we have two cases. First is mercury, in which get depressed. Second is water, which rises. So we can say for mercury, which is depressed, so we can write, and the height is same. Okay. So we can say hg will be 2 gamma hg, and we have cos of theta hg divided by rho hg, and we have g, and radius is given as mercury is for r1. And the water rises, so you can say for water which rises, so therefore we can say that our hw is equal to twice gamma w cos of theta w divided by rho w, g, and radius in this case is given as r2. And we are given that height of depression is equal to height of rise, which is given as h, and it is above given. So therefore, let us call this equation as equation 1 and this equation as equation 2. So you can say from equation 1 and equation 2 we get it as 2 gamma hg cos of theta hg divided by rho hg, g, and r1 is equal to twice gamma w, that is water, cos of theta w, rho w, and g we have, this is r2. Two terms, 2 and 2 cancels, g and g cancels out, and we are supposed to find out r1 by r2. So we can write this as that our r1 to r2, r1 by r2 will be equal to rho hg cos of theta hg, and we have here rho of water divided by, we have here gamma of water cos of theta of water, and here we have rho of hg. So ratio is given, so we combine them like this and we substitute the values. So we can write r1 by r2 is equal to, the ratio of their surface tension is given as 7.5, angle of contact for mercury is 135, and we have here cos of 0, and the ratio of mercury to water is given as 13.6, that is their density. This is multiplied 13.6, so which can be written as 7.5 multiplied by this will be minus square root of 2 divided by 1 into 13.5 or 6. 13.6 is given, 6. So therefore we can write that r1 by r2 will be equal to 0.39, which is approximately equal to 2 by 5. This is the ratio of their radii, and the options that are available to us, you can see option number C is the correct option. So you can say option C is correct. Here we are only interested in magnitude, okay? We are not interested in minus sign. So this completes the question. Or in other terms, we can also say that the H for mercury is in the downward direction, whereas H for water is in upward direction. So those will be, if you take this as mean position, so H in one case will be positive and other case it will be negative. So either ways it will be giving us a positive answer. Okay. So this completes the question. Thank you.